Welcome back, everyone, and welcome, Martin. Hope you enjoy JNation, and we are very happy to have you here today. I will remember you all again that you can ask questions on YouTube channel or on Slack. Feel free to ask anything. This talk will be about React. And Martin, if you can please introduce yourself and proceed with the session. Thank you very much.
Good afternoon, everybody. Thanks for joining me today. My name is Maarten Mulders. I work at InfoSupport as a consultant and as a trainer. One of the trainings I deliver is actually a React training. And that's also what I'm going to talk about with you today. So React. And as you can see, there's a nice sticker in the slide which says awesome sauce, because I believe that the React framework that we will be discussing today is in fact awesome sauce to work with. Now, 50 minutes is not a lot of time, so let's skip all the other duties and go straight to React. What is React? React is best described as a library that lets you build user interfaces in a declarative way using JavaScript, and optionally you can use XML as well. Now, declaratively means that we don't have to tell the library how exactly to build a user interface, but rather we can focus on what we want user interface to look like. And user interfaces is actually a very broad term. React is very popular in the web application development scene, but you can also use it to build other interfaces. I've seen examples of AR environments. You can even build PDF files, which you could say is kind of a read-only user interface. The user can read, but cannot interact with the user interface. And the last part, which is also interesting, is that you optionally can use XML. And that's really strange. If you are used to the JavaScript world, you will not see XML quite a lot. And now, all of a sudden, it pops up. And we will see how exactly that works. But first, let me compare React to a few other contestants in the fields. And there we can see that React really differs from other libraries and frameworks. For instance, two-way data binding, something that got very popular with AngularJS back in the days, is something that you will not find in React. Two-way data binding means that whatever happens in the DOM is automatically reflected in the running application, in the memory, and vice versa. And in React, it's one-way data binding for a reason. Also, React does not have its own templating language. It does have JSX, and you might argue it looks like a templating language, but in fact, it is not. It is XML, and that's how you should treat it. React lets you build user interfaces, but it lets you do nothing else than that. So things that you might have come to expect from other libraries, like routing or built-in HTTP clients or services or dependency injection, is all not there. It's plain JavaScript. And if you wish, you can add JSX or TypeScript. JSX is actually almost always used in combination with React. And I think TypeScript is definitely worth considering if you're starting to build serious applications. And last but not least, React works with a virtual DOM. It does not immediately work on the actual DOM itself, the document object model that lets you manipulate what is visible to the user, but it works with a virtual DOM, which eventually gets synchronized to the actual DOM. And that's a big difference as well, which also makes that React allows you to build very performant web applications. So before we dive into React, let me give you a quick refresher of modern JavaScript. If, like me, you've been working with JavaScript for quite some years already, you may be surprised to see some constructs in typical React applications or frameworks, or actually documentation of React, that at first sight may seem a bit odd. So let's run through a couple of things that have been added to the JavaScript language over the past years so that we are all on the same page there. The first thing that you can do nowadays in React is classes. You can actually use classes and instantiate objects from a class. What we see here is a simple class, which is called an amount. And if you want to construct an amount, you need to pass a currency and a value. Now, this may have looked like a slide deck so far, but I've got a little surprise for you. We can actually start typing here, and our code is going to be executed immediately. This lets me demonstrate to you how certain constructs work without having to leave my slide deck. And here, as a first practical example, we can see that if we have the amount class, we can instantiate an object from that class, pass it some constructor parameters, and then invoke a method on that class. That's really powerful, and it will let us do a lot of things that were previously a lot harder to achieve. Before, if you have worked with JavaScript, you may have seen things like function prototypes being instantiated or invoked and such. We don't need to do all that trickery anymore. So the next thing that I want to show you is functions and how they are defined. You may argue, hey, that's a pretty old concept in React. We have seen that in JavaScript. It's been there for ages, and that's true. But nowadays, there are more ways to write a function than the way we are used to. Of course, this is the way we're used to write functions, and we can invoke a function, pass it some value, and see the outcome of it. That's all fine. But we can also write arrow functions. And depending on what you're exactly trying to do, this can become a little bit more concise. I can still say is even passing a number, but I can even make it a one-liner by removing a few things here and there. Now, this is a pretty concise way of defining a function, and it's a valid way to do in JavaScript nowadays. Another common pattern is object decomposition, which lets us have an object and decompose that object into its individual properties. In the first line, we see an object being created with a few properties, a name, an age, and an occupancy. And in this second line, we see that the object is being decomposed into new variables. So I can say, for instance, there's a variable name by now, and it has the same value as the property name. Same holds for age, but since I did not decompose the occupancy, it's undefined, and I don't see anything at all. It's as if that variable just wasn't there. The same holds for arrays. We can also decompose arrays into their individual members. So we can refer to the first element of the array or the second element, but we cannot refer to the third unless we decompose it that way. Now, the opposite of object decomposition, you could argue, is object shorthand notation, which lets us create objects from local variables without having to repeat name, value, name, value. What we see here is that we have some local variables, name and age, and we compose them into an object, which is called person, by saying, I want to have a property name, and the value should be the local variable name. I want to have a property age, and I want its value to be the value of the local variable age. And we can add more properties if we want. So we can say occupancy is whatever. And now we can inspect the object by saying JSON stringify for the person. And we see the object being composed with the shorthand notation and the old longer notation. Another very powerful feature that you can see quite a lot in React applications is string interpolation. Let me show you what that looks like. I have my amount class again. And here I'm going to say that we have 150 euros. And I would like to have a string representation of that. The string representation lets us use a variable by putting them by creating a string in backticks using $, and curly braces to actually insert variables at a particular point in the string. Note that we cannot say value. We must say this.value here because it's an instance variable. Now, this is not a really very useful representation, but this already looks a lot better. So that's for string interpolation. We've seen some common things that have been added to JavaScript over the last few years and which will allow us to write powerful applications using React. On to what makes React React. And the first thing that we need to discuss there is JSX. Now, what is JSX? JSX is an extension to JavaScript. That means we're not talking syntactic sugar here. We're having something on top of JavaScript that lets us use XML values as a first-class citizen in JavaScript. And please note that we're talking real XML here. So it's not a string of characters that happen to be parsable as XML. No, it is really XML. What is very powerful here is that we can use embedded expressions in JSX. We'll see some examples from that later during this talk, and that we can also leverage attributes from XML. As far as I know, it's not possible to use namespaces. There are boundaries to what is sane in this context, but nevertheless, it's a very powerful mechanism. And since it's XML, we can actually nest XML tags inside other XML tags, which is very powerful again. And if we are using XML or any markup language, then anybody who is a bit familiar with application security and secure development will say, hey, how about XSS? How about injection attacks? What if I would have a local variable that contains some XML like string? So a string that starts with less than, be bigger than, for instance. Will that actually make it into the XML? And the good news is, no, it will not. JSX comes with automatic XSS prevention, which of course you can work around if you really need to. But the way to do that is so complicated that even after years, I still cannot remember how to do that. I need to look it up every single time I want to do it. They made it so hard that you can absolutely not do it by accident, which is good, I think. The interesting thing is that since JSX is a syntax extension to JavaScript, it means that browsers and most JavaScript runtimes do not know about it. And that's why we need a process to transpile the JSX into real JavaScript code. And that transpilation is often done by Babel or optionally by the TypeScript compiler. And until React 17, it would replace JSX by a call to react.createElement. Starting with React 17, you can opt in for the new transform, which will do a little different thing than react.createElement. But let's forget about that for now, for a minute. And let's just say that if you write some JSX somewhere in your JavaScript file, that at runtime you will not see the XML, but you will rather see an invocation of react.createElement. So what would that look like in practice? Here's our first very little example. We see on the first line that we create an XML literal. Please note that there's no string characters here. There's no quotes around it or something. It's just div and a closing tag for div. And you can easily add text in between as you would in any XML editor. And you will see that our text gets rendered. The second line, I'm not going to show you every time, is actually how you bootstrap your React application. So you load the document object model bindings of React, and you tell React to render an element. The element is being created there. And where do you want to mount it in the existing page? Well, find me a document object model element with the identifier app. And I would like to mount my application there. So an element can be anything that is already existing in the document object model, such as a div. But if that was all, it wouldn't be so powerful as it is today. Before we go further, let's just say that elements can also have attributes, as we can see here. So I can create a div with an identifier, not very useful for this example. But if we can do an ID, we can also do different attributes, like, for instance, class name. That's already an interesting one, because in regular HTML, you would say div class is red text, and the text would appear, obviously, in red, even when you type blue. But since class is a reserved keyword in JavaScript, it wouldn't make sense to have class there. The transpiler would simply not be able to make sense. Where is the statement that I need to transpile? And that's why they decided to call it class name. So the names are a little bit different. And as you can see, the name is also camel cased rather than having a dash in between, as you might have come to expect from HTML. Also, their behavior can be a little bit different. For instance, if I specify the style attribute to a div, I can pass it an object. Yes, literally a JavaScript object. And a JavaScript object can describe the style that I would like to apply to my div. Here again, I created a style that lets you display text in red and with a bold font. And even when I type blue, it will appear in red and with a bold font. But you can see this is something that would not work in HTML. We're actually passing a JavaScript object, a JavaScript value, as a value for the attribute of the style of that particular div. So this is really a difference in behavior from what you might have expected from HTML and JavaScript without React. Now, another thing to keep in mind is that an element must always have a single root node. So in this example, we get an error message from React, which says you have two React elements. And I don't know how to render that. There's no way for me to do that. There's a simple trick how you can solve that. First, you can put in between a comma. You put square brackets around them. Hereby, you create an array with two elements, and each element is of type JSX element. So now we have an array of two XML tags or elements, if you wish. And that array can actually be rendered by React. Alternatively, you can use fragments, relatively new feature in React, which does more or less the same thing, but then you don't need to have the comma in between. The interesting part here is, by the way, that this also is different from regular XML, because here we have an XML tag that does not have a name, something that would be forbidden in regular XML. It does have a name, by the way. Officially, it's called react.fragment. And you see it behaves exactly the same, but because that's quite a lot of work to type, we'll just stick with an empty XML tag. That means a tag with no name. Now, that's all fine and good, but the real power comes when we start talking about components. A component in React is a function that takes properties or arguments actually and returns an element. So this allows us to start thinking about reusable components. What we see on the first line is a component that returns an element, an XML element with a div and some text in between. And as you see, it's a function, it's an arrow function just in one line here that has one argument, which is called props. And by convention in React, it's always props. Can sometimes be a bit confusing, but you can, in your head, if it makes more sense, you can just think arguments. And in fact, given that it's JavaScript, you could name it anything and it will still work. But no matter where you look, all documentation will talk about props. properties. And if you want to use such a component, you use it as if it were an XML tag by opening it and either self-closing it or closing it with a closing tag. And here it's interesting to note that if you start writing components, their name must start with a capital letter. By convention, if a component starts with a lowercase letter, it is expected that the runtime binding, in our case, that's the document object model, provides the component type natively. That's why the div here starts with with a lowercase d, because the browser knows what a div element is and it can render it itself. The browser does not know what a greeter is, so we capitalize it, thereby saying we are going to tell you, React, what a greeter is. Well, in fact, it's a component that will render a div. And then if you start rendering the greeter component, again with an uppercase G, then React knows to invoke the function and using the return value of that function to build your user interface. So we've seen the basics of XML in JavaScript, or just JSX for short. Let's look at some more advanced use cases of what you can do with JSX. The first thing, and I already mentioned that briefly, is the fact that you can embed expressions in JSX. And let me show you a few examples of that. Here I have a component which is called example, again with an uppercase E. It does not take any arguments, but it could well have taken some if we wanted to. And it will return a large div over there with some text in it. The answer to the ultimate question of life, universe, and everything. Oh, and now there I would like to actually include that answer. Well, we all know what the answer is. The answer to the question of life, universe, and everything is, of course, 42. A local variable, referencing a local variable, is an expression. So we just write the expression over there. But invoking we can also use a literal value there, works equally fine. And we can even invoke functions here. And then the return value of that function is a value in itself and will be embedded in the XML. As I said earlier, there's prevention against XSS. So if I would include B42, or it's already B, let's do I. As you can see, the I is not executed as if it were in the XML itself. It's taken as a literal value. So that's the XSS prevention I was talking about earlier, live in action here in this demo. Now, as I said, we have got properties that we can pass to a component, or arguments if you wish. How can we use them? Well, if we render a component, we specify those properties or those arguments using attributes. This looks like a regular XML attribute, and in fact, it is. How can your component access it? Well, that's of course where the props come in. As I said, the props is just one argument. No matter how much properties your component takes, there's always one props argument. And we can just use that here and say, give me, please, the name of the props object. And we can pass it in and it will be rendered. And if I update the value of the attribute, then my component gets updated. And eventually the document object model gets updated, and we can see that it reflects in our user interface. There is an alternative, which is to use object decomposition. And it allows you to, rather than say props, you can say, I have a property, or excuse me, I have a function argument here that I immediately want to decompose into a variable with the name name. And if I want to use it, I don't have to do props.name because there is no props, but rather I can do name. And then again, of course, if I change it, then it will be updated immediately. And the only difference, a bit subtle maybe, is the fact that you use the curly braces there. So as to specify, I'm not expecting one object, I'm expecting an object and I want it to be decomposed immediately. Of course, I could try to decompose it into things that are not there. Then it will not work. But passing in a different value, a different attribute for that works. And even if I would pass in a JavaScript literal, so a number, then it will work. So the next thing that I want to show you is how to apply control statements inside JSX. In its most shortest form, this is what it could look like. I have an emotion component over here that, depending on my mood, lets me either clap my hands or dry my tears. If I pass in happy with the value of true, then the props gets decomposed into the local variable happy, which here is evaluated happy and then follows a regular ternary operator. If happy, then clap hands, else dry tears. I could also have written if happy, curly brace, return clap hands, curly brace, else, etc., etc. Quite a lot of work, but sure, you can do that. Something like this. If happy, return clap hands, else return dry tears. And this would also work. And if I would then say, oh, I'm not happy anymore, then I could start drying my tears rather than clapping my hands. So it behaves exactly the same way. And this is how we can make a conditional expression inside JSX. So depending on some local variables, I can either clap my hands or dry my tears. Perfect. Another popular control statement is, of course, looping over a collection of values. And here I have, in line 7, created an array of 2 ticker symbols of 2 famous Dutch companies. Curious if you know from heart which they are. VIA is Philips Electronics Devices. Heija is Heineken, some popular drink, although I think it's more popular outside the Netherlands than it is inside the Netherlands. And I can add a third one and it works perfectly fine. What does it do? I pass that array as a property to my ticker list. The ticker list here takes the symbols, and for each symbol, it will invoke this function that I pass using map. And what does it do? It invokes this function and it creates a new array for where each element in the original array symbols is replaced by the return value of that function, which is the ticker in this case. So in fact, running this piece of code gives me an array of ticker elements. As we saw earlier, an array can be rendered just as fine as a single element. And then the ticker itself is defined over there. And if I would change that ticker, you will see that all the tickers get updated synchronously. So that works fine. And this is how you can iterate over a collection of things. Very powerful. Now, if you're anything like me, you would be looking at this and saying, how does that actually work? What on earth is going on? What's the magic behind the scenes here? Because sure, it all looks fine. I can pass an XML and it somehow gets translated into document object model, but how does that work? And I want to share a little insight under the hood. So there's actually 2 places where the magic happens. The first place is during the build of our application. So we've written a few components, we've wired them together to create kind of a user interface. And as I said, you need a transpiler, and typically it's either Babel or the TypeScript compiler, and it will turn all those XML-like statements, XML statements, or expressions actually, into invocations of React.createElement. So if your JavaScript file contains this XML piece, greeter with name as world, then Babel or TSC will replace that with React.createElement. The first argument is the function that does the actual return statement that returns the XML. The second argument that are the props. So all the attributes that I pass along are taken together into one object, the props. And then the third argument there is if you have any child elements, then it will be there. And if you don't have child elements, like in this example, it's a self-closing element, it will simply be null. And the second piece of magic happens at runtime. Because we have assembled our JavaScript sources and we've replaced all the XML with React.createElement statements, if you load it into your browser will run that code, and it will actually invoke React.createElement quite a lot of times, of course. And all those invocations together form a tree of components. You could think of them as objects, JavaScript objects. So the result of a React.createElement invocation is a JavaScript object saying there should be an element inside the document object model with these attributes and these values and all these whatnot. React assembles that into a virtual document object model. And it's important to note that this is a virtual document object model. So it's not the real document object model yet. Now, this virtual document object model is compared to the actual document object model. So that is the thing that is in your browser, the thing that you would see if you would use your development toolbar in your browser. You could say inspect element, and then you will see the document object model as it is at that point in time. The virtual DOM is compared to that actual DOM, and React will then make the smallest possible changes to actually make sure that the actual DOM is again synchronized with the virtual DOM. That process is called reconciliation. And reconciliation works in React based on two very important assumptions. The first assumption is that if we look at two elements of a different type, then the subtree under those elements will by definition be different. And the second assumption that we need to maintain is that child elements of the same type can stably be identified during re-renders using a special property called key. So let's dive into both of those assumptions. And it's important that we know about these because they let us write efficient and performant applications. So first, about the elements being of different type. It's a little bit larger example here. What we see, we have an application, and the application is defined here. It's a component, and it takes two arguments, a language and a name. And depending on the language, it will delegate to another component, a Portuguese greeter, a Dutch greeter, or an English greeter. Now, by default, it will be English. If somebody specifies a language that we don't know, we will just use English. Given that I have specified the language to be Dutch, it obviously loads the Dutch greeter, or actually delegates to the Dutch greeter, which shows the Dutch flag and the text "Hello, world." Now, if we decide because of some user action or because of something that changes in our system, that the language is no longer NL, but it is rather PT, we see that the app is re-rendered. So this function is invoked again using the new values for lang and name. Name didn't change, but lang did. And because lang is now PT, we see the result of returning the Portuguese greeter. If the first assumption was not there, React might have thought, oh, well, let me see, there's a div in the English greeter, there's a div in the Portuguese greeter, there's a div in the Dutch greeter. They're all divs, so let me dive into it one level deeper. And then it would need to make a very deep comparison of actually the whole document object model. Maybe to find out that not much has changed, but most likely to find out that a lot has changed. So this assumption is actually allowing us to immediately say, hey, if you are rendering a Portuguese greeter rather than a Dutch greeter, I can just throw away whatever was rendered by the Dutch greeter, this whole first div with hello. And I can, instead of that, I can replace that with this piece of XML, which says I. I'm not sure if I pronounced it correctly. Please forgive me about that, but might sound something like that. Let's just go for English just to be sure, because I know how to pronounce that. It will replace with hello. So this first assumption, let's React quickly decide what pieces of the user interface will stay and what pieces will need to be replaced. On to the second one, which is a bit more tricky, but it's also a bit more common to make mistakes here. We're looking at the same ticker list again. And let me again add ASML to the list. Now, what would happen if I would remove the middle element, Philips? It would be very hard for React to say which of those three items was to be removed, because they're all the same. All three of them are a ticker, and all three of them are thereby, as far as React is concerned, the same thing. It can't differ between those three. So React would have no other option than to throw all three of them away and then recreate all of them, except for Philips, who would unfortunately have left the building. This is, of course, very inefficient, because as humans, we can immediately see, hey, Heineken is still there, ASML is still there. Why don't you just keep those? Well, because React doesn't know they are the same. They are, after all, React is, after all, being passed a new array of ticker elements. And yeah, there's simply no reference, no relationship between the old and the new, except if we pass the key property. Because the key property here lets us tell React which element is which element compared to the previous or the other thing that we are comparing with. So it's very important for that key property to be there if you are iterating over anything. And it's important also to obey the rules of the key property, because it needs to fulfill two conditions. It needs to be stable and it needs to be unique. Unique meaning that every element in this list must have a unique key property. And you can do that in our case because tickers are unique. You can just simply use the name of the ticker, and that's just fine. If you are loading data from a remote REST API, then you probably have some kind of identifier for that record. Could also very well fulfill that requirement. And the second thing is that it needs to be stable. So if we run it again and again, we need to have the if we run the ticker again, then the same symbol should lead to the same key. So far we've seen quite a lot of things about how you can build your applications. Let's quickly see how we can interact with our environment, because a web application that only displays stuff, that's not interesting. The first thing is that we can keep state inside a component. And we use react.useState for that. React.useState returns an array, and the array has two elements. The first element being the actual value of the counter, and the second element being a function to update it. In this case, it's a bit boring. It doesn't do anything. And to be able to do that, we need to be able to react to an event. Reacting to a document object model event works similarly as it does in the browser, but again, there's a few subtle differences. The event names are different. We have onClick with a capital C rather than a lowercase c. An event handler must always be a function. You can't delegate to the name of a function. An event handler is always bound to the React component where it lives, and it cannot live globally. And the event handler will receive a synthetic browser agnostic event, which makes sure that it works the same across all browsers. What does that look like? Well, here I have a button. I say on click, I want to pass a function, and the function is defined here as being a function that calls setCounter. And I could say setCounter, counter +1 or counter -1. And now if I click the button, you see that the counter gets updated. Why? Because clicking the button calls the event handler. The event handler calls the setCounter function, which we got from react.useState, and it updates the state, and then the component gets rendered again. Same thing for onChange callbacks, for instance. So we can use string interpolation here again. We can say, show me a pop-up with the name. I can start typing, press the button, and then you see over there a pop-up appearing. Another thing that you do very often when you build web applications is retrieval of data over HTTP. As I said, React doesn't provide you anything out of the box for that, but the good part is your browser does. Every modern browser nowadays supports the Fetch API. Let me show you a quick example here, which retrieves a random joke from a serverless function that's running in the Oracle Cloud that I've hosted there. We have a function which is called getJoke, and the function is implemented by saying fetch to that particular URL. If it succeeds, check if the status is in the 200 range. If so, resolve the promise with the response of the promise, parse it to using JSON, and eventually pick out the joke property from it. And that function is loaded here using getJoke. And I can now say set joke, set state, joke loading, like so. Doesn't work as I expected. Why is that? Set state joke loading. Set state. Don't see why it's not working. Ah, yes, joke, and I'm not loading anymore. And as soon as I say loading is done, then the joke gets rendered. That's because here at the end we have if loading, then always show the text loading, else return the joke. We use a different hook here, which is called React Use Effect, and that lets us attach an effect to the first time loading of the component. This empty array here makes sure that it doesn't fire every time that we load the component, but only the first time. For storing data, you can use the local storage and the session storage, which are both part of the web storage API. It's important to note that if you go that way, you need to write them as strings, which means that any objects you want to work with should be stringified and parsed using the JSON global variable. And if you want it to be persistent over a browser shutdown, you should go for local storage. If it's only relevant during the browser session, you should go for session storage. But then again, that's plain browser JavaScript. There's nothing React specific in there. So given the time that we are on, I want to quickly run through delivering applications, which is actually, it is important to know about it. If you start working with React, I highly recommend to install the developer tools so that you can actually have a component-based view of your application and inspect the components that React has detected. And it also greatly helps in debugging, because here you can see your original source code rather than the transpiled source code. Testing is done using Jest and the React testing library, which makes sure that you can just run a React component in a unit test without having to fire up a browser. Let me skip the examples for now, because we otherwise don't have time for the questions. You can set it up all yourself, but I highly recommend to use Create React App, which gives you a very opinionated, but also ready to roll setup for shipping professional applications. And it uses all best practices from companies that have been working with React over the last years. You install it using the npm package manager, and then you run Create React App and followed by the name of your application. If you've done that, you can use npm run start to start developing with hot reloading and stuff. You can use npm run build to create a production-like build, minimized and everything, and npm run test to run the unit test. There's a lot more stuff. If we had a little more time, I would have told you about custom hooks and about React 18. Well, that's unfortunately not for today. What I would like you to take away, if you start working with React, please use Create React App. Saves you an enormous amount of time in setting up a pipeline. Start thinking of your user interface in terms of preferably small components. And finally, think in a declarative way. Think about what you want your user interface to look like rather than how it should be built. And with that, I hope we have a minute or two left to answer some questions.
We have a couple of minutes, but we don't have questions so far. So everyone, if you have questions about React, now is the time to ask them.
In the meantime, I've added 2 links here, which you can use to check out the things that I've described. Create React App is found online. So is the code for the API that gave us the random dad jokes. And if you're interested in how those work, you can check them out.
Okay, so we still don't have any question, but if you have any question later on, you please feel free to ask them on Slack. And Maarten, I'm not sure if you are on Slack. If you are not, please join Slack and join the discussion there.
Yes, I will definitely do that. I don't think I joined yet, but I will do that straight after the presentation.
Okay, thank you very much for being with us, and hope to see you again in a future edition.
Okay.
Likewise.
See you.
Thank you, Maarten. Thank you.
It was a real pleasure. Thank you for having me.
Thank you very much again. Bye.